Tapered roller bearings in equipment such as gear drives, speed reducers, and machine tool spindles require very little attention and service. If the bearings have been properly installed and are adequately lubricated, a long, trouble-free life can be expected. It is neither necessary nor desirable to tear down auxiliary equipment solely for the purpose of bearing inspection. If a unit is being disassembled for general inspection or a routine overhaul, the bearing should be inspected at that time. The inspector will have to decide if the bearing should be reused or replaced. In most instances, the cost of tearing down and rebuilding a unit is so great that it's better to replace any questionable bearings rather than reuse them and take a chance on problems developing later. Bearings should be removed with care, and the use of proper tools is essential. There are several methods used to remove tight-fitted cones and cups. Here we show the use of a guillotine puller, a device found in many maintenance shops. When removing the cone, the puller should be adjusted so that it contacts the face of the cone but does not contact the cage. The cage should be free to rotate when the puller is in position. It's sometimes practical to pour hot oil between the cone OD and the rollers while applying pressure through the puller to assist in the removal of the cone. The heat will expand the bearing cone, making removal easier. If pullers are not available, use a properly maintained mild steel bar to drive the parts off. Do not use hardened drift, center punches, or brass bars. The hardened drift or center punch may damage the bearing or shaft or splinter and cause personal injury. Brass bars chip easily, which may cause problems if chips get into the bearing or housing. A bearing that has been removed from a machine should be washed first with clean kerosene or solvent in a small washing tank. When only a few bearings are to be cleaned, or if the bearings are small, cold kerosene or mineral seal is recommended. For large bearings or large quantities of bearings, use heated solutions in large tanks. Neutral oil with a viscosity of 100 Seybolt universal seconds at 100 degrees Fahrenheit should be heated to 300 degrees Fahrenheit. And when using alkali cleaners, such as trisodium phosphate, soda ash, and metasilicate, mix them in a ratio of 2 to 3 ounces to a gallon of heated water. Do not use steam or water for cleaning bearings because they'll rust in a very short time. After the bearing has been cleaned, it should be dried with a compressed air gun. Hold the cage with your thumb and blow air through the bearing from one end of the roller to the other. Whenever air is used to dry a bearing, be sure the air system has a moisture trap and always wear eye protection. Warning, do not spin the bearing at any time with an air gun because the rollers may escape from the cage and fly out of the bearing, creating the risk of being struck. Injury could result from being struck by the flying rollers. The clean bearing is now ready for inspection. Typically, inspection of the cone and cup begins by using good lighting and a magnifying lens. Look for signs of scoring, excessive wear, contamination bruising, heat discoloration, or spalling. If any of these conditions exist, the bearing must be replaced. When inspecting the cone, direct a light source through the bearing to view the cone race. A thin metal wire is commonly used to probe the cone race for evidence of pitting or spalling. Cup inspection requires careful viewing of all surfaces, especially the race. Nicks and gouges can be examined for displaced metal by running your fingernail over the suspected area. Light nicks and gouges can often be removed with emery cloth. However, if heavier damage exists, the bearing must be replaced. If, after inspection, the bearing is found to be in satisfactory condition, it should be dipped in oil and, if it won't be used immediately, wrapped in clean oiled paper. If either the cup or cone is damaged, replace both. Never replace only one component. The used component has a distinct pattern worn into its raceway. Combining it with a new component could cause edge stresses along the races and result in premature bearing damage. Shafts and housings should be checked for size and repaired if necessary. In the event that long service has made shafts undersized or housings oversized or distorted, consult the equipment builder for the correct rebuild sizes of the parts. It's important that the proper shaft and housing sizes be maintained, since they can greatly affect the adjustment and operation of bearings. All seals and closure parts should be inspected and replaced if they are worn or damaged. Worn seals allow dirt and water to enter the bearing housing. Proper maintenance of bearing seals is vital to the good performance of any bearing. Along with bearing inspection, the shaft and housing should also be checked. Burrs on the shaft or in the housing must be removed or bearing parts won't seat properly, causing misalignment or faulty bearing adjustment. Also, burrs and chips could work loose and enter the bearings during operation. To protect new or recently cleaned bearings from wear, all parts and assemblies that contact or operate with the bearing should be thoroughly cleaned. Particular attention should be paid to the oil pockets and channels in the housing to remove any loose chips or particles of dirt which may have accumulated. For protection against dirt and moisture, Timken bearings are packed in cardboard cartons. Replacement bearings should be stored in a clean, dry place and should not be removed from the cartons until ready for use. It is not necessary to wash new bearings because the rust-preventive coating on them will mix with all recommended lubricants. After a new bearing has been removed from the carton, it should either be installed immediately or placed on a clean surface. Never place bearings on the floor or on a dirty workbench. Also, don't leave them exposed in open trays, pans, or cabinets where dust, dirt, and moisture can reach them. Extra care on your part will be repaid in the future with longer bearing life. Bearing assembly is governed by the same general rules as bearing removal. Smaller bearings can be pressed or driven onto shafts or into housings. Drivers should be used for assembling cups and cones. These drivers assure easier assembly by driving or pressing cones or cups straight, and they'll prevent damage to bearing cages and nicks in the bearing parts. It is very important not to damage the cage by pressing or driving against it. Pressure against the cage will result in it becoming distorted and loose. Distortion will cause skewing of the rollers. Loosening of the cage can cause the cage and rollers to fall off the cone. If drivers are not available, a properly maintained mild steel bar can be used to drive cones onto the shaft or cups into the housing. Use mild steel, not hardened drifts or brass bars. When bars are used as drivers, extra care must be taken to make sure they are tapered to clear the bearing cage and that they contact only the bearing face. Drivers should be used whenever possible because they'll save time and ensure more accurate assembly. When assembling cups in hubs or housings with a press fit, particularly in aluminum or magnesium hubs, shrink them in a deep freeze unit. An alternative method would be to use an alcohol bath cooled with dry ice. To enable the cup to slip into place, it's sometimes necessary to heat the housing in addition to cooling the bearing cup. Do not freeze standard class cups below -65 degrees Fahrenheit or -54 Celsius, and do not freeze precision class cups below -20 degrees Fahrenheit or -29 Celsius. Check final seating of the cup against the shoulder in the housing with a feeler gauge. Heating is recommended for all larger size press-fitted bearings, including precision bearings. However, care must be taken to make sure standard product bearings are never heated over 300 degrees Fahrenheit or 149 Celsius, and precision product bearings are never heated over 150 degrees Fahrenheit or 66 Celsius. If bearings are heated over 300 degrees, they'll begin to draw or soften. Heating precision bearings above 150 degrees may result in increased radial runout. One method for heating bearings is infrared lamps. This method assures minimum handling and maximum cleanliness. However, for accuracy and temperature control, the Timken Company recommends the use of heating devices that are thermostatically controlled. Electric ovens that are thermostatically controlled are one of the best methods for heating bearings. Electrically heated oil baths that have thermostatic controls can also be used. If an open flame or a hot plate is used to heat an oil bath, never rest the bearing directly on the bottom of the pan because it will absorb heat directly from the heat source. A simple wire screen holder or similar device should be used. Never use a torch to heat bearings. Torches get extremely hot and it's difficult to distribute that heat evenly. Heat-resistant gloves should always be used to handle heated cones.